When it comes to the terms microwave and optical fiber, microwave is a line-of-sight wireless communication technology that uses high-frequency beams of radio waves to produce high-speed wireless connections that can send and receive voice, video, and data information. And on the other hand, optical fiber transmits data through light to a receiving end where the light signal is decoded as data. This has a transmission medium of a pipe which carries signals over long distances at high speed. So before beginning the session, I would like to give a brief introduction to our resource person, our guest speaker today, Engineer Buddhika Vijayatunga. Engineer Buddhika Vijayatunga is a product of the Faculty of Engineering, University of Peradeniya. After obtaining his bachelor's degree in electrical and electronic engineering, he obtains his master's degree in electrical engineering from University of Moratur. He has more than 9 years of experience in the field of telecommunication, which he started as an engineer in Transmission Planning Division at Dialog Axiata Private Limited, where he later became the assistant manager. After migrating to Canada, he joined Crosslinks Transit Solutions, and currently he is working as a project technical specialist in Communication Systems Division of the largest transit expansion project in Toronto's history. So dear sir, it's a great privilege and honor to have you here with us today. And thank you very much for joining with us and to share your knowledge and experiences with us in spite of your busy schedule. And I hope the participants will be able to get the best out of today's session, where they will be discussing the promising trends and component development and industrial applications of optical fiber and microwave links. So without further ado, I would like to invite Mr. Buddhika Vijayatunga to start the discussion. Dear sir, over to you.
Thank you very much. Thanks for the introduction. So first of all, I must thank IEEE IAS chapter in Peradeniya for inviting me to conduct this webinar. Actually, I consider this as a real honor to conduct this webinar to the undergraduates of my own university. So this is the first time I'm conducting a webinar to the undergraduates of Peradeniya. So thank you very much for inviting me. So without further delay, I will start my presentation. Right. I hope everybody can see my presentation. Okay. Right. Right. So the topic I'm going to discuss today is the applications of optical fiber and microwave links used in data transmission. So this is a broad scope. It's really hard to explain everything in 1 hour, but I'll try to explain everything, whatever the important aspects of these two fields within this hour. So this is the lineup for today's webinar. The first part of this webinar is the microwave links, and next I will discuss the fiber optics section, and at the end we can have a quick discussion if you have any questions. So during the session, if you have something, please note it down. We can have a quick chat at the end of this presentation if you have any concerns on the presentation. Right. So when we talk about microwave and optical fiber communication, it is important to know the electromagnetic spectrum and the uses of it. So so for microwave and optical fiber, we are using this electromagnetic frame and the highlighted section. Not every frequency, but frequencies within this range for the microwave communication and optical fiber communication. So if I explain this data transmission thing in very simple words, let's say we want to communicate a message. So our normal audible range is 20 to 20,000 hertz, but that is that the attenuation of that frequency is really low, and the range is really low because of that. So what we do is that, let's assume we need to pass a message to a friend, right? And in traditional way, we can write a letter, and we can write a letter, and we can put it into the an envelope, and then we can hand it over the postman. He will deliver it to the friend, and he will open it, and he can read the message. So just like that. So microwave communication is like that. So we need to pass our data stream. So we will use a carrier signal from microwave or the infrared range, and we modulate that message. So that is similar to we putting this into an envelope, and the postman, he will do in the data transmission part, and when it receives to our friend, he will open it. That's demodulation, and he then he can read the message. So that's in simple words what we really do in this data transmission using microwave and optical fiber. So we will start from microwave communication. So what is microwave communication? So microwave is a point-to-point communication technology which used line of sight, a wireless communication technology that uses higher frequency beams of radio waves. So we can use this technology to communicate with with two locations, and we can send voice, video, and data information using this technology. So this is in very high level what is microwave communication, and the most important thing is we need to have line of sight to establish this connection. So this is the general setup of a microwave link. The first we need to identify the basic components of a microwave link. So in a general setup, we have IDU, so that is indoor unit. So we normally place it in the in an indoor space like this, and then we have the IF cable running from IDU towards the ODU. So here you can see this square is the ODU, which is connected to the antenna. So this is, so here you can see 3 antennas, but for a microwave link, it can have maybe 1 or 2 antennas depending on the configuration. So this is, I would say, half of a microwave link. So you need to have a similar setup at the other site where we need to communicate from this location. Right. So these are the basic components and type of microwave links we have in the industry. So if I talk a little bit more about the components, we have IDU. So the task of IDU is to receive, transmit, and receive the services, and it multiplexes those services, right? And also they process those services, and it will convert the baseband signal into a IF signal. That means intermediate frequency. And then and also the IDU provides the system control and the communication function, like the network management system. So that will be performed by the IDU. Then we have this IF cable, the intermediate frequency cable. So the main task of this cable is to transmit the IF signal into the outdoor unit. That means the ODU. So the task of ODU is the processing of IF to RF transformation. So that's the purpose of ODU. And also we have the antenna. The antenna, this focus is to receive the RF signals as much as possible. And we have a parameter called antenna. Again, we will discuss that in our next few slides. And we have we identify normally these antennas from its diameter. So we have diameters from 0.3, 0.6, and likewise up to 3.7 meters. So depending on the application and the path loss, we need to select the correct IDU, ODU, and the antenna. So we can discuss a little bit in next few slides on how can we select those equipment. And the next thing I would like to discuss is um, the mounting of the ODU to the antenna. So based on that, we can say it's direct mount or it's separately mounted. So here in this top one, in the direct mount, you can see the ODU is directly connected to the antenna here. And here you can see two ODUs are directly connected to the antenna using a coupler. So we call there is a plate you can see here. So that is the coupler. It can couple two ODUs together and connect it to the antenna. So that is direct mount. So the separate mount. So here you can see two ODUs here, but they are not directly connected to the antenna. So we are using a waveguide to connect these ODUs to the antenna. So these are some general terms we used in the industry. I thought it might helpful for you when you go for your internship or even for your job. So this might be helpful because usually we don't talk these things during our academics. And if I talk about the general arrangements of the microwave links, so depending on the ODU and the antenna, we can uh, categorize the microwave link arrangements into three main categories. The one is the trunk radio. So you have uh, all these IDUs and ODUs, everything in an inside location, and you have a waveguide from this unit towards the antenna. So that is called the trunk radio. So this was used in few decades back. I don't think these trunk radios are used anymore. Um, the next thing is, and the most common microwave link is the split mount radio. So in the split mount radio, you have IDU. So basically split mount is this arrangement. You have IDU here and you have IF cable running to the outside, and in the antenna you have in the tower you have the antenna and the ODU. So that is split mount. In all outdoor radio, maybe in the tower or pole, you can have all together outside. So that is all outdoor radio. So this is kind of new technology in the current industry. The next thing I would like to discuss is the frequency bands that we used in microwave communication. So here you can see in this table, there are a lot of frequency ranges allocated for different applications. This is this highlighted area. Um, that is the traditional microwave frequency area. So basically, it is from 7 gigahertz up to 26 gigahertz. So that is the traditional microwave frequency band. But right now, there are newer microwave links which uses from 40 gigahertz to up to I would say 90 gigahertz. So these bands also uses the used as the microwave links, but when the frequency is high, uh, the uh, the the applications may differ, and the distance becomes really low because of the attenuation. So I think earlier we used to have micro links from 2 gigahertz range also, but due to the access technologies, um, some of the frequencies were left off for the access technologies, and it was limited into this range. So that is about the frequency bands. Um, so uh, so the goal is to set up a microlink. So before we go into that, it is important to know some technical terms about microlink planning. The first one is the polarization. So polarization means, as you all know, it's the electrical field is horizontal, and in the vertical polarization, it is vertical. So a microwave can be horizontal or vertical, depending on the application. Actually, we can configure this in the microwave, whether we need horizontal or vertical. And there are some newer microwave links. We can use both these polarizations together. We call them XPIC links. So there are some links like that. Next thing I would like to discuss is the radio channel. So based on our bandwidth requirements, we can select bandwidths. It can be 7 megahertz, 7, 14, 28, and 56. So we need to get approval from a TRC to use the to radio channels, and also we need to pay for TRC annually for this frequency. I mean the channel, for the channel bandwidth, we need to pay for them, and also we need to select two carrier signals, one for transmission and one for transmit and one for receiving. And then antenna gain. So antenna gain is directly related to the frequency and the signal area. That means the diameter of the antenna. So the goal is to capture as much as the wavelengths as much as possible. So when we can capture almost, I mean, a lot of wavelengths, then we can have a good signal receiving. So if the frequency goes up, then the wavelengths become shorter, and it will increase the antenna gain. And also, if the diameter goes up, it will allow to capture more signal, more wavelengths. So because of that, the antenna gain is going up. So these are the two important parameters we need to consider about the antenna gain. And the next thing is the K factor. This is something interesting. So we are sending this electromagnetic signal over the atmosphere, and depending on the refraction, this ray can bend either up or down. And we can calculate this using formulas. And if the K factor is more than 1, so that means the beam is bent towards the Earth. And if it is less than 1, so that means the ray bends upwards. So this is important when we do the link budget calculation. The next thing I would like to discuss is the line of sight and the Fresnel zone. So at the beginning of my presentation, I told you that line of sight is the most key thing in set up a microwave link. So without line of sight, we cannot set up a microwave link because it will interrupt the signal path. So this reminds me a funny story. So when I was in Dialogue, we used to have a lot of interns from almost every university in Sri Lanka in the engineering section. So the first question received to those interns is that, okay, so can you set up a microwave link from Sri Lanka to India over the sea? So because you don't have any obstructions over the obstructions in the sea, so can you do that? So I mean, maybe even you can think about it right now. Can you do it? So most of the time, people forget that that we have a curvature in the Earth. So basically, we forget the Earth bulge. So the Earth bulge may become an obstacle, even though we don't have any obstructions in the sea, the earth bulge may become an obstruction because of the curvature of the earth. So we need to consider that also. So we need to have line of sight, and we need to have something called Fresnel zone. I'm not going too deep about what is Fresnel zone. You will learn these things when you do the antenna and propagation module. So the goal is to have 60% of the so we need to have clear 60% of the first Fresnel zone boundary, so that the signal become so we have a clear receiving signal from the transmitter. Um, so this picture explains how the Fresnel zone works. So this is the line of sight and the Fresnel zone. It has a very clear line of sight and Fresnel zone. Here you can have line of sight, but the Fresnel zone is interrupted. Here you don't have a line of sight because this is obstructed by this tree, and you don't have a good Fresnel zone clearance. So the goal is to get at least 60%. But when we plan a microwave link, we try to have this kind of setup because it will make our life easy. And the other thing is, trees don't stay like this; they will grow. And let's say we set up a little microlink like this. So maybe in few years, this will become non-line of sight case. So it is always good to have this kind of setup. And then I need to talk about the losses. So this is really important when we do the link budget calculations. I will go through them. So first we need to calculate the free space loss. So depending on the frequency and the distance, the free space loss will differ. We need to calculate that. And then we need to consider about the rain fading, and depending on the rain intensity, this may differ. And diffraction loss. So if we have an obstacle in Fresnel zone, we need to consider the diffraction loss as well. And the multipath fading. So if you check this figure, you can see when the signal transmits over a water body, so the receiver might get different signals in different paths. So this may occur the multipath fading. We need to consider this if we plan this microlink over a water body. And the other thing we need to consider is the equipment aging. So with the aging, the transmitting, the performance of the transmitter and the receiver reduces, and we need to consider it when we do the link planning. And we talked all of these things just to make sure that we need to calculate a link budget. Basically, that means we need to set up a microwave link from site A to site B. So we can consider this as site A, and this one is site B. So here we have a transmit power. Then we need to consider all the losses throughout the transmission medium, and what is the receiving power he is getting. So we have a standard standard set of receiving parameters, and based on that we will do the link budget calculations. Normally we need to consider about the availability and the receiving power when we do the link budget calculations. So there are two ways of doing the link budget calculations. One is the manual method, and the other one is using a software tool. Manual method, it's really long. The calculations are really tough. So that's why we have softwares to make our life easy. So usually microwave product vendors produce their own planning tools. But if you have different vendors in your network, it is good to use a software like Path Loss, because it will allow you to have all the microwave products in one tool, rather than having three or four separate tools for individual microwave vendors. It's easy to have one tool for everybody. So these are some snapshots I've taken from the path loss tool. So from this tool, you can get an idea about the line of sight and the geography of the area from a particular point. So uh, so it's this picture explains this red zone means there is no line of sight. Uh, so likewise, and this picture explains it's how we do link budget calculations. So basically, we need to set up the antenna sizes, transmit power, and we need to set the rain intensity, the things like that in this window. So this is how the geographic area in a particular mm, uh, in a particular site or a location. So here you can see the sites and how they are connected, and you can see how the terrain looks like. And this is another important thing we can see. So we can see the how the signals are transmitting from site A to site B. So based on this, we can adjust the height of the antenna to get a clear signal path without any obstruction. So I mean, learning path loss is another, I would say it would take a lot of time. It's not that simple. Um, I mean, it is simple, but to get a better understanding and to configure this path loss into our requirement is it's challenging, because we need to find the detail, the geographic terrain data and the correct standards. We need to put that into the software to get the correct results. But path loss is a good tool. I have used this tool. It's a really good tool, and it will make our life lot of easy. Then I will quickly go through the types of micro links we have in the industry. So we started from SDH and PDH micro links. These are full DDM micro links. I don't think we are using these micro links anymore. Then then we got the hybrid micro links. So in hybrid micro links, you have native TDM services and Ethernet services, and these can be transmitted through the AI interface. Right. Then we received the next evolution of the micro links is hybrid or packet integrated micro links. So in this micro link, we can transmit one type among or combination of native TDM services, native Ethernet services, or PWE3 packet services. So it's quite similar to hybrid microlink, but it's one step ahead of hybrid microlink. And so when the network becomes fully IP, we don't need TDM services anymore, and we get rid of those TDM services, and we have this full packet microlinks. Even if we need TDM services, we can transmit them over the Ethernet using this PWE3 encapsulations. So right now in the industry, I would say we have this packet microlinks and hybrid packet integrated microlinks. So these are the two microlinks we have in the industry right now. I mean, in the legacy networks, you may see these SDH, PDH microlinks and hybrid links, but the capabilities and the technologies are outdated now. Right. So this is an example of microlink. So we have so these are the two sites that we are communicating. So the arrangement is similar from this side to this side. So we have antennas, ODUs, IDUs, and sometimes we have a switch or a router to connect the base station services like 2G, 3G, 4G, things like that. So we'll connect those services to the switch or the router, and we will communicate those services via this microwave link. So that's the basic arrangement of a microwave link. And here I wanted to show you how an IDU looks like. So this is IDU, a picture of IDU. And this is an example of the interface of the IDO. So here you can see we have Ethernet interfaces, we have event interfaces, and power supplies, fan units, and things like that. And also we have these USB memory slots, and we have some other ports for the network management systems. So from a central point, we can see all the performance and the alarms and everything from a network management systems, rather than going to the sites and see the alarms and everything. So it'll save us some time with the use of network management system. Right. So if we talk about the typical applications of microwave links, so as I explained, we need microwave links to communicate between satellites and or between base stations. And also in telecommunication, we use them as a backbone carrier for cellular systems. And also this is using in short range indoor communications as well. And this one is something this is something really interesting. So there are some research ongoing to use microwave links to measure the rain intensity between two locations. So this is kind of something in research area, but it is not related to telecommunication although, but it's one of the applications of microwave link. So if we have a quick look about the advantages and disadvantages of microwave links. So the biggest advantage of microwave link is we can do a rapid installation. It'll save us time. Let's say we need to have a connection to a urgent site. So we cannot lay fiber in few days. So depending on the approval cycles and the installation work, we need more time to lay a fiber cable. But microlink, we can set up a microlink in 1 or 2 days, maybe even 1 day. So this is really helpful for emergency purposes, and this is cost effective for lower capacities, and it has low planning costs, and this is very flexible, as I explained. So we can quickly deinstall and reinstall this microwave link depending on the requirement. And also this has disadvantages as well. We have limitation in transmission capacity, and also depending on the conditions, we might need some special structures to mount these antennas and everything. And also we might need relay stations for longer distance communication. So that means we need to have repeater base stations in between if the distance is too high. And the other important thing is with weather, especially the rain, it can disrupt the microwave link. This happens a lot because for tropical countries like Sri Lanka, we have heavy rains, so the microwave links can be interrupted during those periods. So this is one important thing we need to keep in our mind when we plan microwave links. And for higher capacities, the cost can go up because I told you that for the frequencies we need to pay for TRC and for the channel bandwidth. So if you're using a higher channel bandwidth, we need to pay a lot of money to TRC. So the cost can go up for higher capacities. And I would like to show you some new trends in microwave links. So we have so with the evolution of the telecommunication, with the when we are now, we all know that we are moving from 4G to 5G now. So in order to cater capacities, we need to have new technologies like this 10 gig plus larger bandwidths. So in order to do that, we need carrier aggregations. So that means we are using 2 channels into one, and using one microlink, we can have these two channels. So with these two channels, earlier you can consider this as two microlinks, but now with one microlink, we can have two channels and we can get a higher throughput with carrier aggregation. So super dual band, this is kind of similar to that, but the difference is we are using the traditional micro band and the E band. So this is E band means a frequency range is above 60 gigahertz. So we are combining the traditional frequency band and the E band, and we increase the throughput. So during the let's say there's a rain. So during that raining period, the E band, the bandwidth of the bandwidth reduce, and we might lose communication between the E band microwave link. But in the traditional microwave band, we can send the important traffic with the use of quality of service. So we can tag the traffic based on the importance, and we can send the unimportant traffic in the E band. So even if there's a disruption, we wouldn't mind, because this is not for, because there will be no interruptions all the time. So when we have interruption, we will still survive the important traffic. So that is how this super dual band microlink work. And we have multiple input output microlinks now. So we use two antennas per side. Then so I'm not going to explain a lot of theory part how this multiple input and multiple output works. So basically, with the use of the these four antennas, we can double the capacity. So that's basically it. And we have the high modulation schemes and large channel bandwidths. So right now, in Sri Lanka, TRC allows up to 56 megahertz. So if I believe the microlinks in Sri Lanka are are capable of going up to 112 channel bandwidth, but we need to get permission from TRC if we need to use that range. All right, so the next section. So let's talk about fiber optics now. So fiber optics is a technology used to transmit information as pulses of light through strands of fiber made from glass or plastic over long distance. Usually we use the glass fiber in Sri Lanka for the telecommunication industry, but depending on the application, we might use plastics or plastic fiber as well. But the glass fiber is the most common fiber cable we can see in the industry. So I would like to talk a little bit about how fiber cable looks like. So we have, so this is a cross section of a fiber cable. So we have a core, we have a cladding, and we have a coating, and we have a strength member, and we have an outer jacket. So this is the cross section and the components of a fiber cable. So this is the core. So this is this explains a little bit more about the core and the cladding. The concept we are using in fiber optics is the total internal reflection. So the inner core has a higher refractive index, and the outer cladding has a lower refractive index. So with the use of this property, the total internal reflection, we will be able to send a light signal from point A to B using this fiber cable. So using this fiber strand. I know you will learn a lot about theories. You will do calculations, how much you can transmit, things like that, when you during your academics. So I'm not going to explain them here. So I'm going to explain generally about just the important factors about microwave links. Sorry, the fiber links. So we have two types of fibers. One is multi-mode, and the other one is single mode. So here you can see the difference. So normally single mode strand diameter is around this range, and uh, the multi-mode fiber strand is around this range. So multi-mode fiber strand is quite larger. And in what is the difference between multi-mode and single mode? So in multi-mode, we can send um, um, light signals in different wavelengths. So this diagram, it shows three light signals are sending over uh, one optical strand. So this is multimode. So single mode means we have only one wavelength traveling inside the fiber strand. And it is, so if you look at this table, we can see the single mode fiber and the multi-mode fiber differences. So we are using different wavelengths. So these are the most common wavelengths used in single mode fiber communication, 1310 and 1550 nanometers. Yeah, we selected, I mean, these wavelengths were selected because at these wavelengths, it has near zero absorption. So that means, um, so so when in near zero absorption, it will avoid the vapor collects in the glass, and which causes the attenuation. Uh, and the other thing is the attenuation in my multimode fiber is higher than single mode fiber. And because of that, we cannot travel longer distances with multimode fiber. So this table explains that. So for single mode fiber, the attenuation figures are like this. It's 0.36, but for multimode, it's over one decibel per kilometer. So based on the application, we will use single mode or fiber or multimode. So if we consider the cable types, so for single mode, we have OS1 and OS2. OS2 is the latest one. Generally, we are using OS2 in single mode. In multi-mode, um, uh, so multi-mode also has there's evolution in multi-mode fiber. So the capacity has increased and the distance has been increased. So obviously it can carry more capacity than a single mode fiber, but the distance is very low. So that's why we have single mode and multi-mode fiber even now. So depending on the application, we will choose single mode or multi-mode to cater our requirement. So the OM5 is the latest version of the multi-mode fiber. And it is important to know what is tight buffer cable and loose tube cable. So a tight buffer cable means so the buffering material is in direct contact with the fiber. So if I explain this in application wise, so let's say we have a fiber cable from between two cities, and if we need to terminate this fiber cable to a city in between those two cities, we need to cut the whole fiber cable if it is tight buffer. So that will add a loss to the whole transmission. I mean, to the whole fiber course, because we are not using all those fiber strands to that intermediate city. We might use one or two strands based on the applications, but because of those one or two strands, we might need to cut a whole cable, which has maybe 144 strands or 96 or whatever the cable we used. So that's why we have a loose tube cable. So in loose tube cable, we have color coded plastic buffer tubes. So inside of a tube, we have 12 strands or 8 strands based on the cable. So we can cut this cable. We don't need to cut the whole cable. If we need to have a interconnection point between those 2 points, we can just cut the tube, and even from the tube we can select whatever the strands that we need to terminate, and we can select those one or two strands, and we can do the splicing of that fiber. So that's the advantage of using loose tube cable. And we have standards, IEC standards and ITUT recommendations. So based on the application and the requirement, so it is the responsibility of the planning engineer to select the correct type of correct type of cable. So in telecommunication outside plant applications, normally we use this ITUT G.652.D cable, a loose tube cable. So that is one of the common fiber cables you can see in Sri Lanka in the fiber network. And I would like to show you some passive equipment we generally use in optical fiber infrastructure. We have patch cords. Then we have the connectors. So we have these are the most commonly used connectors. So this one is FC, this is LC, this is SC, and this is ST. So LC and SC are the commonly used fiber connectors in telecommunication networks. I mean, there are more connectors than this, but I just picked the most common connectors that we used in the industry. And when we talk about the outside plant fiber cables, so the outside fiber cables comes like this as reels. So whatever the distance we need, we can order fiber cables like these reels. And this is a cross section of a fiber cable. So here you can see those tubes. So this is one tube. So based on the cable type and the standard, there can be multiple tubes and multiple strands inside a tube. So if you check a data sheet of a fiber cable, you can see how many strands inside the cable and how many tubes in it and how many strands per tube. So based on the application, you need to select the fiber cable and how many strands you need. So it is up to the planning engineer to decide. And then I would like you to show the patch panels. So, now we have fiber cables, and those fiber cables are coming into a site, and in the site we will have this fiber entrance cabinet. So the fiber cables are coming like this, and they will be terminated in these splicing trays. Usually we terminate these cables here. It is not that we are connecting this fiber directly into a active component like a switch or a router. No, it's not like that. First, we need to terminate them in the fiber entrance cabinet. We need to split those fiber strands into different trays. So this is this is a picture of that fiber entrance cabinet. So you can have multiple trays like this. So in each tray, you can terminate each tube. And from there, you can have a number of cables going outside. Now, let's say this cable has 144 strands, and we can split into 12 trays, and then we can split this into 12 core cable, and we can take one 12 core cable from here. So that cable can go to another, maybe another room. Let's assume this is we have a building. Into the building, there's a bigger cable coming in, and into the different floors, we are using different splice trays and different cables, and into the floor, we will have this rack mounting patch panel. So this is a small patch panel, so it can it can connect, let's say we need to connect 12 strands, and we can splice those 12 strands into this patch panel, and from this patch panel we can connect this into active equipment. Um, so I will quickly mention about the splicing. So we have two splicing methods. One is mechanical and one is fusion. Fusion splicing is the preferred method because it has less insertion loss. Mechanical splicing used in emergency situations where we don't have a splicing machine, so we can use this kit and do mechanical splicing, but the insertion loss is high. For fusion splicing, we need a splicing machine like this. But however, we are using splicing instead of using connectors because the connector loss is a lot more higher than the splicing. So that's why we need splicing. So this is a typical example of how we terminate fiber cables. Now let's say we have two routers or switches at two locations. So from here, we have these are the fiber strands coming from each port, and this will come to a patch panel. And from this patch panel, it will connect to a fiber cable like this. So fiber cable running from site A to site B. So it will be terminated into another patch panel. And from that panel, we can connect these two to the ports of the other switch. So this is the typical arrangement. So that's why we need patch panels in between. Right. So up to now, we talked about the passive components. So because basically fiber is all about passive. But depending on the application or the technology, we are using these SFPs, small form factor pluggable modules, depending on the technology and the applications. So the applications like Zone 8, Gigabit Ethernet, wavelength division multiplexing. So depending on the applications, we have different transceiver modules, same as SFPs. We are call them transceivers also. We can have different transceiver modules. So and for single mode and multi-mode, we have different transceivers as well. So we cannot use a single mode transceiver for multi-mode applications. It's like that. And also we can connect optical cables and also copper cables based on the transceivers. So we have two types also, optical transceivers, which can connect optical modules and also copper cables, the typical RJ45 connector. So this table explains the SFP fiber module. So this is the transceiver types, and this is the connector type, and these are some typical distances and typical data rates. So everything will depend on the transceiver that we are using. So based on the transceiver, we can use our optical fiber infrastructure, and it's up to planning engineer to select the correct cable, correct transceiver, and decide what is the best way of doing the data transmission. Okay, so if we talk about the advantages and disadvantages of optical fiber, the biggest advantage is we can go for higher bandwidths using optical fiber, and we can go for long distances without any repeater sites. So this one depend on the transceiver that we are using, and also the technology that we are using. So whether it's Ethernet or WDM or like that, it will be depending on the technology and the distance. And this is less susceptible to the interference like the electromagnetic the interference. So that's one advantage, and we can use these as submarine cables, which can be submerged in water. So if you Google it, you can find the submarine cable arrangement in the world. So even for that, we are using these fiber cables, but those fiber cables are a little bit different to the cables that I've explained, but the concept is same. And we have high reliability and high scalability, because when I say scalability, let's say we need to upgrade the capacity of fiber link. Let's say right now we have 1G fiber link. Let's say we need to upgrade it to 10 gigs. What we need to do is we need to just upgrade the transceiver module from 1G to 10G, and the lesser cost per bit. So we all know that um, fiber link can transmit a lot of data rate, and the cost per bit becomes really low when the data rate becomes high. Right. Although we have advantages, we have some disadvantages as well. Um, the biggest disadvantage I would say is the labor cost, and the installation time period is really high for optical fiber. Um, this is not, and also this is not cost effective for low capacity transmission, because of the capex is high, and we have some cable arrangement limitations because of the limitations in the bending radius of the fiber cable. But we have different standards for different standards and different fiber cables, which has different bending radiuses, but still this is a limitation of fiber link. And lead time for deployment is high, as I explained earlier. This may depend on the time we need to lay the fiber, and also we need to take approvals from the authorities before we lay a fiber in every country. So that is one disadvantage. And if I talk about the applications of fiber optics in data communication, so in telecommunication field, we use these fiber cables as backbone for wide area networks and LANs. And also now we use these fiber cables for FTTX applications like FTTH, FTTC, premises or building. So based on the location, we use these fiber cables for telecommunication applications like this. And also we use the fiber cables for networking purposes to connect servers and the other network equipment together. And these fiber cables are used in other fields like medical, industrial and commercial, and broadcast, um, um, cable TVs, and things like that. And also, I forgot to mention here, we use the fiber cables extensively in railway industry as well. So we used fiber cables for communication-based train control, which is my current job. So so we use them in railway industry as well. All right. So now we discussed about microwave and fiber. So I would say this is the most important thing. So what's the role of an engineer to select the correct transmission medium? So we need, so the engineer needs to consider these factors when he decides what is the best and what is the most suitable transmission medium for his requirement. First, he need to consider what is the intended capacity and what is the additional capacity demand. So that means how scalable is the solution, and the expected level of reliability. So this will, the reliability is directly related to the customer satisfaction. If the link is not reliable, customer is not happy. And also we need to consider expected timeline. How fast is the solution required by the customer, and also in order to meet the timeline, we need to have a good project management skills. And also how much budget we have provision for the for this transmission medium. So, and also how many operational expenditure that we are expected for this link. So that is financial management. So you can see from your academics, you can get the first two, the technical aspects. I mean, you can do calculations, you can do analysis, everything you can do it like this. But the next 3 points, you cannot get this from your academics. You need to be uh, a good project manager. You need to be strong in financial management and also in commercial aspects. And you need to be a good engineer in all these areas. From that, you can become a good engineer and you can deliver good results. So that is the most important message I would like you to give from this webinar, is that, I mean, everybody can go through the theories because you all are getting a degree at the end. You all are intelligent. You all are capable of learning new things. But learning these 3 points, the financial, project management, um, and commercial aspects, it's really important. So please don't ignore the things like that. That's why you need to uh, uh, you need to involve in extracurricular activities in order to develop these skills during your undergraduate period. So don't be limited to your academics. Expand your time for extracurricular activities to improve these skills, because this will become really important when you go to a new job. So because when I was in dialogue, a lot of undergraduates were trained under me. That is the most lacking part I have seen in most of the undergraduates. They are lacking on these things. So please involve in a lot of extracurricular activities and improve these skills. It will help you a lot when you go to a new job. Um, so, so that's all I have to present today. So I would like to open this forum for everybody who has any questions. So it's time for you now.
Thank you, sir, for the informative yet interesting set of knowledge you've shared with us, and I'm sure the participants were able to get the best out of it. So now it's time for the participants to raise your questions related to today's session. So if you have any questions, feel free to unmute yourself and ask them, or you can type them in the chat box.
Hello, can you hear me?
Yes.
So at the beginning of the presentations, I heard that in the microwave link, we have to consider that a K factor. So
Yeah.
can I know what are the what are the things that we are considering in the K factor and how it's affected to the transmission? Can you explain that?
Right. So in the K factor, so it's purely a calculation. So we need to consider the radius of the Earth and the frequency and everything. Um, so there's a formula to do that calculation. It's a big formula. I can't remember that formula. So you need to work on that formula to calculate the K factor.
Okay, thank you.
And there's another question I can see in the chat. So ask for, can you explain a little bit more on how service providers deal with rain attenuation in microwave links? All right, so for rain attenuation, what we can do is when we do the link plan, we can use technologies like adaptive modulation. So with the adaptive modulation, we can, I will quickly go to that slide. Right. So let's say let's forget about this E-band part. Let's focus on this traditional micro band. Let's assume this is our micro link. So when we have rain, we can use the technology, the adaptive modulation. So with the adaptive modulation, with the rain, the micro link reduces the modulation. So when we reduce the modulation, it will reduce the transmission capacity, and but it will not interrupt the communication between the two sides. So let's say here we have 100 Mbps capacity, but here it might be 20 Mbps. So let's say we have two traffics. We have voice and internet. So based on the importance, we can tag voice as voice is more important than the internet traffic, because we can expect a little bit delay for internet, but when we have a delay for voice, the communication breaks. So based on the quality of service, we can tag the traffic, and we can use this adaptive modulation to get rid of the rain attenuation. I mean, we cannot save the total traffic, but we can save the most important traffic of the micro link, which communicates from site A to B. So that is the one technology that we use to get rid of the rain attenuation. And also we can have we can keep a provision for additional transmission power, so that it can increase the transmit power by himself, so that when there's rain attenuation, the micro link can increase the transmit power also. So that is the other technology we can use to get rid of the rain attenuation.
Hello, sir.
Yeah.
So what is the reason for having like two outdoor units? Is it about like to providing backup or something?
Yes. Yeah. So we have two outdoor units. We have two. I would say we have two applications in having two outdoor units. One is to have redundancy. You are correct. So we can protect one. Let's say we have uh, two outdoor units configured as active and standby. So if one audio fails due to a hardware fault or something like that, we can use the other audio as the backup audio for the communication. So we have redundancy for the microlink. The other use of two ODUs is that we can double the capacity using the using the cross-polar interference link that is called XPIC link. We can double the capacity. So that's why we have one or two audios. It can be go up to 4 audios as well. Let's say we are using 2 channels in XPIC mode. So we can use two frequencies in dual polarization, so that we can increase the capacity 4 times with the use of one microwave link. So based on the application, we can change the capacities, and also the audios can be used for redundancy purposes as well. I hope I explained it clearly.
Yes, sir. Thank you, sir.
So in occasions where the long distance communication is required, it's usually said that it's better to use the IoT for communication, isn't it, sir?
So in terms of transmission for long distance, we prefer to use fiber cables, because microlinks we usually set up them for distances like um, up to, I would say, 20 kilometers, but because of the capacity requirement, we cannot have high capacities for distances like 50 kilometers, 100 kilometers. In our previous networks where we where we had only TDM requirements, that means events, we used to had microlinks for closer to 100 kilometers, but now we have bandwidth requirements around 1 gig, so we cannot have ranges like 100 kilometers with a microlink for that kind of capacity. So the preferred solution is fiber optics in terms of transmission.
Okay, sir.
There could be any health hazards considering the microwave communication?
Yes, so it is not advisable to expose to a microwave link, but the important thing we need to understand is that microwave link is a point-to-point communication. So let's say you have a microwave link in a building that you are working or that you are staying. So that microwave link is communicating as a point-to-point communication. So staying under the microwave link doesn't cause you a health hazard, but if you come in between two microwave links which are communicating each other, that will expose you microwaves into your body. So that may give you a health hazard, but other than that, there is no health hazard unless you expose to microwave links.
Thank you, sir.
Excuse me.
Yes.
Compared to your job role in Dialog Axiata and job role in Canada, what is more challenging one?
If I do that comparison, I would say both are equally challenging, because you might think that Canada is more developed than Sri Lanka. I mean, in terms of financial aspects and things like that, Canada is more developed. But in terms of technology, we are in par with all the developed countries. So there is no challenging to an engineer who worked in Sri Lanka to work in Canada. So if you worked in a company like Dialog, so for me it's really easy for me. It was really easy for me. There is no challenge at all, because what I've learned in Dialog in Sri Lanka are into, I mean, those are very valuable. And those are the latest things in the industry that we used in Dialog and in telecommunication industry in Sri Lanka. So I would say it's quite similar.
Thanks.
How can we have the multipath fading when we transmit in between hill countries where there are more mountains and sort of thing where the humidity is high?
So when the distance is when the distance is high, there is a possibility that we can get multipath fading. So for solutions, solutions for multipath fading is to have diversity, frequency diversity and space diversity. So we can have separate set of antennas or separate set of frequencies to avoid multipath fading. And also we can lower the antenna height to get rid of the multipath fading. So that will be that is kind of a troubleshooting thing, the lowering the antenna heights. So we can test this at the site. When we get the multipath fading, we can lower the antenna height. And also we can use, when you learn about antenna and propagation, you might learned that we have main lobes and side lobes in microwave communication. And also, if you have a lot of multipath fading for shorter distances, this is for over water bodies. For shorter distances, we can set up the microwave link with the use of side lobe as well. That will get rid of the multipath fading as well, but that is for very short distances. Mostly, we will get multipath fading when we communicate over water bodies. So that's how it happens.
Seems like there are few other experienced engineers from the industry presenting today's webinar. So we would be really grateful if you can share your experiences or knowledge regarding this area.
I'm really sorry, I couldn't hear you properly.
It seems like there are few other experienced engineers from the industry presenting today's session. So the society will be really grateful if you can share your experience and knowledge with us if possible.
I'm sorry, I can't hear you properly. If you can type it quickly, maybe I can answer.
It is not actually a question, sir, but it seems like there are few experienced engineers from the industry presenting today's session. So as the club,
Okay.
we will be grateful if they can share something with the participants regarding
All right.
today's session.
Okay, right. I believe the question is for the other engineers who participated to this webinar. Not a question actually, just to share their experience with the undergraduates who are attending this this webinar.
Yes, I like to add something as Buddhika highlighted. The academic qualification is very important, so no doubt about that. So that is your first priority. So basically, that will help you to climb the ladder. But not only academic qualification is important, but also you need to learn to handle the pressure, and you need to learn to communicate with the people effectively, and you need to be more patient, and you need to listen to others. So these are the basic qualities you need to have when you are going to the industry, right? So that's what I need to communicate to you, that you all are very good in academics. There's no doubt about that. You are the cream of the society. So education qualification is, there's no doubt about that. But doing the extracurricular activities will help you to gain on other qualities. So that was very important. So that you need to engage in the extracurricular activities. So that will help you to learn a lot, especially how to be a patient, because industry is not something that will basically, it is something very challenging, I must say. So that is not your school time and that's not your university time also. So there are a lot of challenges. So there are a lot of things happen without your knowledge, and most of the things maybe it's not as you wish, right? So then you need to handle the pressure, you need to take the challenge, you need to listen to others, you need to be more patient, and you need to wait for the right time, right? So these are the most important qualities you need to gain when you are going to the industry. So learn a lot, do your academics well, and engage your extracurricular activities. That's very important. So that will basically build a team player. So that's the summary word of everything: patient, communication, and everything. Be a team player and be a leader. So that's what industry need you, right? So then industry, that will definitely help you to climb the ladder. So that's the message basically I need to give it. So yeah, that's it from my side. Okay.
Thank you very much, sir, for the valuable piece of advice. Now I would like to invite